Coming in, but we'll get started to respect everybody's time. Good morning. I am Mark Zaborny, the marketing manager for DME, and I'd like to welcome you to the 2025 DME Webinar Series. Today's session, we are partnered with Staubli for a presentation titled Seal the Deal, Safety First, Leaks Last. This is the first of a series of monthly webinars that we're going to have throughout the year from experts of our industry. Next month, we will be spotlighting Cooling Care, which is an advanced cleaning channel system that tackles scale, corrosion, clogged cooling channels to optimize thermal performance and reduce scrap rates. Registration for that webinar will be opening up next week, so please stay tuned. You can find that registration on our LinkedIn or through emails. If you are not connected with us on LinkedIn, I welcome you to do so. You can find us under DME Company, and there you can find links for registrations for upcoming webinars, more product information, and other important news and events. Today we are joined with Tim Boyce from Staubli. He is the head of business for the plastic market at Staubli North America. We recently included Staubli onto our line at the end of 2024, and we are so excited to share their products in this webinar with you. You will be able to find all of the products that we have that we carry through our eSTORE, and I will be sending out links for you that. Some quick housekeeping right now. If you have questions for Tim or for DME, please submit those questions via the chat in our Q&A, and we'll get to those after the presentation. Also, recording of this webinar will be emailed to all attendees later on this week. Finally, if you guys are attending the PT Expo, both DME and Staubli will be at that show. So if you have questions too, please join us in the booth, and we'll be happy to discuss anything with that. Without further ado, I would like to welcome Tim Boyce. Tim, the floor is yours.
Thank you, Mark. It's a real pleasure for me to be here today and be part of DME's webinar series. Thanks to you for organizing and the DME team for giving us the opportunity. I should say as well, thanks to everybody online for joining. It looks like we have a growing audience. People continue to be added. So thanks for taking the time to everyone and for your interest. It's appreciated. I really do hope you find today informative and helpful. What I've tried to bring is as many real world examples to the topic for today. So I hope that makes it relatable and productive and a good use of everyone's time. As Mark said, please share any comments or feedback in the chat as we go. So I will jump in, and here's the first slide. Okay, so as Mark mentioned right away, these solutions that we're talking about today, they're already live and they're available on the DME eSTORE. From Staubli's side, we are very happy to partner with DME. It's a company that has a long and successful history in the plastics market. I think I saw DME started in 1942, so that's 81 years. Staubli has been making fluid connectors since 1956, 68 years, so not quite as long, but we're very happy to work together and bring DME's customers Staubli's range of high-performing connectors. So now I just said high-performing, and that is really my goal today, to explain where some of the issues with connectors come from, what's behind a good functioning connector, and how they can help companies improve their overall efficiency in molding operations, whether it's connecting mold circuits for water, hot oil, or hydraulics. So here's an example. This might look familiar to many people on the call. It's not easy to capture leaks on video, but I'm sure that many of you who are working or have worked on the shop floor have seen many similar situations to this one, and you probably have a strong intuition as the impact on efficiency, on part quality, and safety when leaks like this occur. In this example, what happened was the main O-ring seal between this connector's plug and socket was worn out, and it became dislodged, causing a leak during operation. This one's slightly different. This time, the internal O-ring for the valve on this connector had an issue that got worn out. And so here the leak happened in the disconnected position. Same result though, some machine downtime, and unfortunately for this operator, he had to climb into the machine for water. So the plan for today is to talk about leaks from quick connectors, as well as issues that can affect connector locking mechanisms and potentially causing accidental disconnection. That's quite a safety risk. Solutions for connecting with residual pressure in hydraulic circuits. And finally, to share some details around connector performance in terms of ergonomics, and also ensuring that any pressure losses or impact on mold cooling can be mitigated. So I hope that sounds okay. I know Mark said he would interrupt me if there's any technical problems, but I think it's going well so far.
So far, so good.
Okay, a brief introduction about Staubli. We are a global company. We have 4 divisions, and what ties them together, it's really innovation. Staubli's aim is to offer advanced solutions to increase our customers' efficiency. On our website, it says innovative solutions for higher productivity. I'm part of the fluid connectors division. We also have an electrical connectors division, robotics. They make robots and AGVs. And the original one is a textile machinery division. So with that focus on innovation, the company is very proud always of our investment in R&D and engineering. So you can see here we have 600 specialists and application engineers around the world, and the company holds over 2,000 patents. In terms of size, Staubli is available in 50 countries. We operate in 28. Our global workforce is around 6,000 employees, and the combined turnover of the 4 divisions is 1.6 billion Swiss francs. Okay, so I mentioned that Staubli's been making fluid connectors for 65 years, but this company actually started back in 1892, 133 years ago. That was the original textile machinery group. This slide shows some of the company milestones, and I hope it gives you a good impression of the experience that Staubli has with developing these technical solutions for different manufacturing companies. For fluid connectors, the division I work for, plastics is our biggest market. Today, we're talking about connectors that you can find on DME's website. But for your interest, Staubli also designs and develops other quick mold change solutions, such as magnetic clamping and mold loading products with some automation. You can find out more about that on Staubli's website. Here are the connectors now at DME. These first 3 are for mold cooling. So we have a full flow option, that's our RPL connector. We have a double shut off connector, that's the RMI, with integrated valves so the water gets checked automatically when the connector is disconnected. And the third one is also double shut off, but this time a special valve design where it's flush, no drips come out of this connector at disconnection. That's very useful for high temperature applications in particular. And we have 2 hydraulic connectors, also drip free. And the second one here in particular has a feature that helps when there's some residual pressure in the hydraulic circuits. Okay, so what is the cause? Where does these issues come from with connectors that injection molders face with their fittings and couplings? Here are a couple of very recent photos. This is from a customer who's just ordered some CBIs. On the left, it's nice photo because you can see the connectors aren't quite straight, and there's an obvious bending force being applied on the connectors. It's coming from the bend radius of the hoses and the weight of the hoses that are filled with fluid. They're always applying some amount of load right at that connection point. In the middle, it's just a still photo, but everyone knows injection molding is a rather dynamic process with the opening and closing of the mold, plus additional movements from cores and slides and stripper plates, cycle by cycle. On the right is kind of the result with the motion combined with the loads put on these fittings. This photo of the machine door, you can see on the window a lot of residue from the persistent leaks and spray coming from connectors that have failed. Here you can see wear on some plugs, and here both the sealing surface has been affected as well as the locking groove. This is a ball and sleeve locking mechanism on the socket. They should fit in that groove. And in that middle photo and the one on the right is quite an interesting example of a Brunelling failure, where some oscillations or pulsations in the circuit have caused those locking balls to actually indent the plugs. That's compromising the locking, and it also means that the O-ring will no longer sit correctly and it won't seal between the plug and the socket. A couple more examples. These times, at least the leaks aren't next to the mold. They're not inside the machine, but connectors mounted on the back of the thermolators around the machine, and obviously still causing a mess, creating a risky environment for employees and generally reducing overall productivity at these companies. So what can we offer to help? Well, there are two key design features that help withstand these forces and motions and keep a leak-tight connector. Firstly, you can see the length of Staubli's profile compared to other solutions that are on the market. It makes it much stronger mechanically. It's giving good guidance as the plug and socket come together. They're well aligned, so it's not wearing out the seals inside the connector. And after it's connected, that length allows the connector to handle the loads much better. You can actually feel this when you're handling a Staubli connector. There's a very minimal play between the plug and socket compared to other connectors on the market. Okay, and this is the same for all of the products. They generally have this longer profile, especially the one on the right. That's our CBI connector. That's designed specifically for applications that have high vibrations and oscillations. Despite the length though, there's a couple of counterbore examples shown on the screen. Even though they're a bit longer, they are designed, and it's possible to add that counterbore on the mold to make sure that the plug gets seated and it's mounted flush to the mold surface, and they're protected so they don't get damaged over time. That was the first feature. The second feature goes hand in hand with that strong alignment, and that is the position of the seal, or where the sealing is done between the plug and the socket. The photo on the right, that's a very common design approach where the nose of the plug for this connector creates a face seal against that red O-ring at the bottom of the socket. With a Staubli connector, the one on the left, the sealing is actually done on the side. It's not on the front of the plug, it's around the circumference of the plug. Together with that strong alignment, that significantly reduces wear, and it keeps those connectors leak-free over time. All of our solutions are designed this way. Here's the close-ups to see connector by connector where that seal is positioned. It's the one on the right, you can see it's actually a double O-ring seal, again, still around the circumference of the plug. So mechanical alignment, the side sealing for Staubli, those are the key to having leak-free connectors over time. Now, beyond leaks, connecting and disconnecting should be quick. They are quick connectors, but it can create ergonomic issues like you're seeing here with this operator, and potentially even safety concerns. So in this case, the issue with this connector was the locking sleeve got jammed, preventing the locking balls from engaging properly on the plug. It's causing a headache for this operator. I think this might be maybe a nuisance or an ergonomic issue. Maybe the real safety issue comes later if this connector doesn't connect well and there is a potential accidental disconnection during operation. Accidental disconnection, that is especially risky when there's hot oil and water, and a risk for burns of the operators that are using them. Is when connectors inadvertently pop off during use. It does seem frequent, unfortunately, so much so that there's a common solution. It's kind of a band-aid solution, I think, that companies take. They install those red and blue plastic clips behind the locking sleeve, trying to make sure that locking sleeve can't move and can't come disconnected. Here's 4 photos from different companies who have each implemented this solution. Somehow it does seem inevitable that these plastic clips can get missed. And in fact, you might have already found the missing clip in each one of these 4 photos. So the same challenges with sealing are also affecting and potentially compromising the locking mechanisms, leading to that accidental disconnection. It can also be exacerbated by dirt or debris getting underneath the locking sleeve. Here, the choice of the construction material for those critical locking surfaces is important. All Staubli parts have some form of hardening or a stronger material beyond raw brass. Brass is really the default material used by most other connectors in plastics. It's cheaper, but it's also softer. If you look at the RMI, for example, that's the one in the middle of Staubli's solutions. Those material choices are what give it the increased robustness for the locking. So it has 6 locking balls, very similar for most 3/8 inch connectors in this example, but the plug is made of hardened steel along with the corresponding locking balls, and that locking sleeve is also made of steel. The RPL on the left, that is nickel plated brass. This time the design's changed and Staubli has added and has now 8 locking balls to better manage the forces for this connector. And finally, the one on the right, that's our CBI, both stainless steel locking surfaces and up to 9 locking balls. Is really the ultimate connector we propose for those applications with lots of vibrations and oscillations. I should mention as well that valving in connectors does also add a layer of safety at disconnection. In this case, the fluid would be automatically shut off at disconnection, and especially the flush face design, the one on the right, these valves are touching together, so there's no space between them, and therefore no fluid can escape when that disconnection happens. That's why we recommend this one for those high temperature water and oil applications. For our full flow solution, that's the RPL on the left, that actually has a very nice safety feature. The lock is designed to require 2 very deliberate actions in order to open the connector. Got an animation to show you here. So you can see as it runs, the connector actually has to be pushed together first before that locking sleeve can be pulled back. This means it can't be knocked off by accident, and also that there's no need to use one of those plastic clips that can get lost. And speaking of robust materials, for hydraulic applications, as the pressure in the circuits increase and there's a higher separation force on the connector, here Staubli uses even stronger materials, and not just the locking surfaces in this case, but the body of the connector and the back adapters of the connectors are made of steel for that higher internal pressure. And now on this one, as an example, this connector has 10 locking balls, given that higher force is being applied during its operation. Both of these hydraulic connectors have this flush face connector or non-spill valve that I was describing. No oil dripping out, but also helpful for hydraulic circuits is that it doesn't allow any air to get into the circuit during the connection, which can happen with some other styles. If there's poppet valves, for example, often some compressible air can get into those hydraulic lines. Okay, and now just as a side note, since I was mentioning valves, I thought it might be interesting to share one thought Valves can actually be quite interesting and helpful for companies that are trying to follow a SMED process, reduce their mold change times. We see a lot of lost machine time for draining waters from a mold into a bucket often, and this is happening while the machine is idle. It's not making any parts. So having a valve in that quick connector can facilitate or make a way that draining the mold can be externalized from the mold change process. It can be done after the mold change, once that machine's back up and running, maybe on the floor or back in the mold shop. Even just leaving the water in the mold, that's quite common if that mold's going in and out of the machine frequently, and that'll save some time on the mold change process. Okay, so back to connection issues. This one is a little specific, but you might have seen it in your facility. It's often when there's no return to tank function on a machine, on the machine's hydraulic core circuits. The typical kind of brute force solution is for a setup technician to head over to their toolbox, grab their hammer, and try to crack open the valve to relieve some of the pressure so that they can run the mold. Happily, Staubli has developed a pressure relief solution. You can see it here. There's a very small bleeder valve on the nose of this CBX connector, and the operation is done very simply by pushing the connectors together. No specific tools required. As they get pushed together, that bleeder valve's open, it lets some pressure out. It allows the valves in the connector to travel back into the circuit and the connection to be made and locked. This is our CBX connector, and these part numbers with this feature all have that PA designation at the end. Okay, so the last section is really around performance, and performance in terms of how these connectors function for the people that are using them, the process technicians, the mold setup team, tooling guys in the tooling room, and also performance in terms of how the connectors function relative to the internal flow and cooling of the mold. So this video, it's nice to see how easy it is to operate this RPL connector. At Staubli, we call this locking design fully automatic, in that it's simply push to connect. There's no need to pull back a locking sleeve before making the connection, just push it together. All of those Staubli products, with the exception of the RMI, that the RMI family is, we call semi-automatic, where you do have to pull back the sleeve. But the other ones shown today are like the RPL, they're automatic push to connect solutions. Very helpful for improving ergonomics. Here's an example of kind of a hard to reach place that we often see. If the mold has water outlets on the bottom, it's hard to see where you're connecting, and for an operator just to be able to reach under and push it to connect, very helpful for these types of applications. As a side note as well, that this is the connector with that two-step disconnection. That can actually be done with one hand, holding the hose and then pulling with the thumb and forefinger to make those two distinct actions. So I think it still works very well ergonomically, connecting and disconnecting in this kind of a situation. Okay, so in terms of flow performance, I know many process techs get worried about the idea of introducing a valve in the connector. They're concerned if any sort of restriction or impact on flow rate can affect cooling of the mold. So I thought it would be worth mentioning a few details. In these photos, you can see the care that Staubli puts into the valve design. Some complex machining, conical shapes or smooth radii, all of that to make sure and try to maintain laminar flow through the connector. We make flow charts available. You can actually, if you want to quantify the performance and check the size of the connector is appropriate with the valves for an application. Here you would need to know the flow rate going through the specific connector, so not the overall flow rate from the thermolator, but circuit by circuit, what is passing through that connector. If you know that in gallons per minute, you can run up the chart and across to see the expected pressure drop. Another thing in particular I think that's good to mention is the real performance benefit with those non-spill valves. On the left is our RMI. This is the traditional design. It has a stem valve, and you can see there's a valve in the back of the socket and there's a valve in the back of the plug. As that fluid is passing through, it needs to go around those two features. If you compare that to the path of the fluid going through a flush face connector, here the valve, they're not at the back of the connector, they're right at the front and they're right together. So the flow, as it's going through, it only has to pass around one feature. It makes it much more efficient. And on the next slide, I can show you that same point in a slightly different way. If we take a trip through the connector, this is the double shut off, so going around the first valve and then around the second valve, compared to a trip through a flush face connector where you pass the valve holder and then it's really just that one valve that the fluid is traveling around, making it quite efficient. Here's a comparison as just one example. So here the flush face connector with the same flow rate of 5 gallons per minute has a much better performance or much lower pressure drop compared to the double shut off one. Okay, so for the time remaining, I have a few examples of Staubli connectors in the field. Here you can see some water connectors. The first one is a mold that's got some CDIs and RPLs. Some RPLs in the middle one shown on a manifold stack. On those clips, there is actually a small spot you can even write the circuit number. So we've got a visual indication of in and out with the red and the blue. You can also mark up the connectors to make sure circuits, the circuit numbers are being connected correctly. This one is that one I actually showed this a little bit earlier in the presentation, where this customer was struggling with that Brinelling failure. And you can see going from that solution on the left, they've now installed RPL sockets on their molds. At the bottom of that red hose is the RPL plug ready for connection. A couple more of the RPL. This is a nice contrast between molds of different sizes. You can see the RPL is being used for a lot of internal circuits as well for this large mold. And on the small mold, it's looks like 4 circuits on that mold half, so a little bit smaller. Okay, another small mold, and an interesting one to point out here is the larger diameter connector at the bottom of the manifold. So the RPLs are for those 3/8" circuits going to the mold, and the large diameter connectors coming from the thermolator, those are our RMI 25 connectors, 1 1/4 inch diameter, which is quite common for manifolds like this. Some other examples of that product being used. This is actually something we see more and more interest with a solution for large diameter connectors. A lot of customers seem to use cam lock connectors that are full flow, and there always seems to be some residual water inside those large hoses that spills out onto the machine during every mold change. Over time, our customers report they get damage to their tie bars, even rust on the skates under the moving platen that damages the ways. Can be very expensive to replace. So the RMI 25 is a great option to add some check valves and make sure that water stays in the hose and it doesn't spill and damage the machine. This is also, I think, a nice example This customer has a machine with a rotating platen on the moving side, and they've also got a Staubli magnetic clamping system. That's the steel with the brass rings. That's our magnetic mold clamping solution. You can see the power connector for the electrical going to the magnet is right below those connectors. So in this application, with that motion coming from the rotating platen and the proximity to that electrical connector, I think the CBI was a great choice. Non-spill connector is going to manage those forces very well. And then another one, similar setup on that machine with CBIs coming off these water outlets on a rotating platen. A couple of hydraulic ones. The one on the left, you can see both Staubli's MPX and CBX next to each other. I think you can guess what the customer's trying to do here. They're trying to error-proof the connection. So male and female to error-proof the set and pull, and then two distinct profiles. So the hoses from circuit 1 and circuit 2 can't be cross-connected by mistake. And finally, a couple more applications where you can see both hydraulic connectors and water connectors in the same on the same machine. This is a vertical machine on the left, the CBI for water, and the CBX for right on those hydraulic cylinders. And on the right, again, that large diameter RMI 25 in the bottom of a manifold, together with some hydraulic MPX quick couplings on that mold. Okay, so hopefully these examples have sparked some interest. To let you know, there is lots more information. DME has done a great job of putting technical details on their eSTORE. Here's a screenshot. You can click on the product sheet section for each of the Staubli solutions, and that'll bring you to the technical data, a nice summary of the operating parameters for each of the connectors, and that flow chart I mentioned to do some, quantify the performance of the connectors for your application. Also, maybe even better is to reach out to the DME sales team. They all now have demo samples of these Staubli connectors. It'll be great if you can reach out to them and get a chance to see these connectors and feel them in your hands. That'll give you a feeling for some of these features and benefits that I've been trying to share with you today. And finally, as Mark mentioned, PT Expo, DME is going to have some of these Staubli connectors in the booth, so you can take a look and again get your hands on these products when you're at the show. Okay, so with that, I will exit the presentation, and we've got some time for questions. Let me turn my camera back on.
Yes, if people do have questions, please put them in the chat and we will get to them. First question I have is there increased risk of clogging compared to conventional alternatives? Can these fittings be cleaned?
I mean, when there is a valve inside the connector, there is a smaller path for that fluid to go past. I don't know if that really increases the risk of clogging. That may become more from residue on the connectors. These connectors, RMI, CBI, and the CBX connectors, they all have rebuild kits available. So if something large like I'm guessing maybe you're thinking about a piece of steel in a hydraulic circuit or some buildup of calcium or something in the water, if something large like that does get in the circuit, they can be taken apart and rebuilt. It's kind of, I don't know if I answered it well. I'm not sure if it's a higher increase of clogging, but you can open them and clean them out. So hopefully that's answers it okay.
Perfect. And if not, if you guys need to follow up, please, put that in the chat. The second question we have is, do we know how much money can be wasted over leaks in production?
Yeah, that's an interesting question, because often when we meet with our customers, we're trying to help them come up with a reasonable ROI, or return on investment. And so we're always trying to think about what is the real implication or costs that these are causing. I would say, I mean, there is just a lot of variation company to company because of the different consequences. So for example, in a medical mold or in a clean room, if there's a spill that gets onto a mold there, that's a much higher impact, a much more extensive cleaning process is required in that type of molding. There was one study that showed leaks can cost between 1% to 5% of operating profit. I think it's worth looking at company by company. So costs can come from the downtime for fixing the connectors. It can come from the damage to the machines, like the rust around the skids or the tie bars over time. It can come from mold repair cost, especially molds that have a high surface finish. And if that gets rusty, it's very tricky to smooth that out, like automotive lighting applications, for example. We actually had one customer that had water and rust on those high polish cavities, and just taking the cost to ship the mold to the tool room and back, that shipping cost alone was enough to help them justify the investment of having that non-spill connector. You know, there's also going to be costs, of course, from quality issues if there's containment required or sorting those parts. And ultimately, as well, in the worst case scenario, lost time instances if there's an injury for hot oil or water and an operator.
Sure. Okay, this next question I have is, how does Staubli compare to traditional connectors on flow rate?
Generally, they have in better flow performance than other connectors. In that, I did have that one slide showing some of the attention to detail that goes into those internal components and making sure that they're smooth surfaces to go, you know, for the flow to go through the connector. It's quite easy to answer specifically with a specific application. If we know the fluid, the temperature, and the flow rate, then we can check with our team exactly how that performs. And it's relatively easy to find that information for other alternative connectors as well. So I think that would be maybe the best way to answer that question.
Okay. Again, if everybody has questions, please put them in the chat. We have a couple more here. Are the flush face connectors good for clean room applications? And is there any leakage that would contaminate when disconnecting?
It's ideal. That's the one that we really recommend and seems to be quite popular for medical molders. There's basically, we call it no drip. In reality, there is like a film, like just from surface tension on that surface, but it's literally a question of wiping it off. And they work very well in those environments, exactly kind of what they're designed for. So yes, for sure.
Perfect. Let's see, we have, do you have any more case studies around leaks like the ones that you showed in the videos?
Yeah, we do work on these ROI calculations, but a lot of that involves our customers' financial details. So I don't have anything that I can share today. But you know, I think working through those costs that I mentioned, those different sources of costs from these leaks, customer by customer, that's the best way to identify their specific situation. Another approach could be to basically take one area of the production plant, maybe take one machine and a few molds, equip it with Staubli connectors and see how that performs relative to the other machines in the molding bay. And that's maybe a nice way to quantify and do an internal case study for your specific company. A lot of our customers might make adapter hoses with their current standard connector on one end and the new Staubli connector on the other, to give them some flexibility. So as they grandfather in, they bring in and change over molds to Staubli connectors, they still have a way of connecting if they have to, as they've done in the past. That would be just another thought for that, trying to identify that case study customer by customer.
Okay, looks like we have one more question left. So if there's more questions out from the attendees, please let us know. Also, to let you know, on our LinkedIn page, we are having Staubli Week. So we will be highlighting a certain product each day. But if you have questions there, if you think of something after the webinar, by all means, you could send us a question over via email, through our reps, through our LinkedIn. We are 100% available to you at all times. The last question I have is, why is the RPL design inverted, with a male plug on the hose and the socket female part on the mold? All other fittings seem to have the plug installed on the mold and the socket on the hose. Why is the RPL different?
Yeah, that's true. I can share my screen again just to show that detail. Actually, here's actually, this is maybe a good answer for this question as well, but this is a clip. I didn't show this earlier. But yeah, you're right. Typically the male side of the connector is mounted on the mold. With the RPL, it's inverted. So it's the female part. The socket is mounted in the mold. I think it's just a design choice. It does bring a couple of features. So that two-stage disconnection that I mentioned earlier, that can be integrated into the plug. And it also makes maintenance of that O-ring very easy. They are designed for long life, but if the elastomers get hard over time, perhaps with high temperature, consistent high temperature over the years, then it does make it very easy to swap out that O-ring if you have the connector designed in this way. I think those are the main reasons why it was done that way.
Okay. What is the oil temperature limit on the CBI connectors?
Yes, I can tell you if you give me 1 second. I'll give you the real answer. So for these parts, all are coming with a fluorocarbon seal. So the high temperature rating is 392 Fahrenheit.
There's that. And then what is the typical lifespan of Staubli connectors?
Typical lifetime, it's really dependent on the conditions, the frequency of connection and disconnection, the forces being applied, the cycle time of the machine, how much they're being moved around. So I don't have a very specific number available, but the idea with these solutions is, rather than having an existing solution where you're replacing seals frequently, these are long life solutions where you don't have to do that. You avoid all that work and you keep them leak tight for a long amount of time. I've asked that question before, and really I think the only way to answer it correctly for each customer is to just install a couple and see and measure how long they're lasting for that application. Environmental conditions can affect it, the temperature of the fluid going through the connector, the actual forces that are being it's seeing, and then again, how often is the mold change happening? Is it happening 3 times a day or once a week? Those are all factors that really change the answer. Sorry, I don't have an exact number.
No worries. All right. Looking at other questions. Last chance for questions. Looks like that we got them all. Again, we will be at PT Expo, so if you guys want to see this, the products in hand, by all means come join us at our booth. Also, all of our DME sales reps have some as well, so you can talk with them. Other than that, if there's no other questions, I want to thank you, Tim, for your time. This is great. This is an awesome webinar that we had here. And if we don't get to any other questions they come in, I think they're all out, we will find you and we will answer those for you. So again, thank you, Tim. Thank you for everybody who went online for this webinar. This is great. Again, keep your eye out for the next month's DME Webinar Series, which will be cooling care. And I believe the next one is AHP Merkel. So we're going to be hitting you guys every month with more and more webinars to get more of education out there and to answer more of your questions. With that, I guess, thank you so much. Thank you, everyone. And have a great rest of your day.